Hello, everyone. This is Linda Westfall from the Software Excellence Academy, powered by the Westfall team. One of my gurus that I have learned so much from over the years is Tom Gilb, and Tom is going to talk about value requirements today. And with that, I will make Tom the presenter and turn it over to him.
Okay, welcome everybody. I'm going to talk for about a few minutes, and that's about one slide a minute. So forgive me for not going into detail, but you'll have the opportunity of reviewing the detail if you wish. The slides are based on a book that Linda just mentioned that I want to give you all called Value Requirements, and you can give that as a Christmas gift to all your friends, something like that. Let's see. So do we know? Yeah, if you want to argue with me, there's my email, and I love to hear from people and get questions and objections and additional insights and things like that. Here is the Value Requirements book. I'm in this lecture. I'm going to do about half of the book, the basics of how to do value requirements, and then what I won't have time to do, but it's in the slides and in the book, is once you've done these value requirements, what can you do with it? Okay, what are the applications and use cases and stuff like that. So that's this 9 to 18. But after I'm done with section part 8, I'm going to stop, and I've got a little slide saying hopefully 50 minutes have gone and stop. Here is the one way of downloading the Value Requirements book. It's only 291 pages. I'm told that the best-selling books on average are 230 pages, so I'm a little bit in excess of that. Okay, so first definition, what are value requirements? Well, if we say that this oval represents functionality, defined as what a system does, whatever it does, okay? You know, run a spacecraft to the moon or something like that. Then values are, in simple terms, we can think of them as qualities of the function, like the security, the user friendliness, the ease of maintenance of the system, okay? But in fact, values are very general. They are anything that stakeholders value having enough and value having more of. Absolutely anything. And that actually is a almost infinitely large category. If they say, I want to see dancing Santa Clauses with Rudolph the reindeer, and that's my value, well, that's their value. Now, one thing I found about the values is you can always say, I want more of that, or we need to improve something or reduce something else. And the moment you can put those adjectives in front of the word, like prove security, you've in a sense proven that it's a variable. You know, it can improve gradually. And so one characteristic of these values is that they are all quantifiable. We can put numbers on them. They're not binary. We don't have security or not security. We have degrees of security up to, let's call it 100% security, right? Functions, on the other hand, are binary. You know, it runs a spaceship or it doesn't run a spaceship, but there's nothing in between. Okay, now the other thing about values is I've discovered that functionality is just, you're a player, you're in the game, you're in competition with other people for the same functionality. But who wins the game? Those are the people who have good qualities and good values which are superior to the competition. So I found that in any project, the critical thing to keep your eye on, and I don't think we're very good at it, are the values. You know, of course, you have to know what the functionality is, and you have to program it into the system, and it has to be there. But the competition is doing the same thing, and in principle, all competition has the same functionality. The differentiation is that some of the competition, like you, design the functionality so it has really good values in directions of, say, security, user friendliness, and any other qualities. So the thing that determines success and failure in our projects and in our products and our services are the values, and having, at least as good and having an edge over anybody else. Okay. Here's another picture. On the left-hand side, we have a whole bunch of stakeholders for COVID. And on the right-hand side, we have some little yellow arrows. They represent the values I'm talking about here. And these are the values for fighting COVID in a country. And we did this as a little exercise when COVID was starting up. Okay. And so you get some idea of what I mean by values by just reading that list, like collect information, education, equipment capacity, funding. And we're going to go into some detail on some of those. The point of this particular diagram is that one stakeholder can have one or more values, and one value can have one or more stakeholders. And if you have a stakeholder like this emergency response service with no values connected to it, it means either you're not listening to that stakeholder or they're not a stakeholder. Okay. But a stakeholder means that they have a stake, and that stake is at least one value they're concerned with. Okay. Again, if you also have this, like, equipment capacity as a value, but it has no stakeholder, it has nobody backing it up and saying, I want it and I'll vote for it and I'll fund it and things like that. So this particular diagram, which is automatically generated when we plan, gives us the opportunity of seeing orphan stakeholders and orphan values. Oops. Here are some other requirement types that I'm not going to talk about today, but so I've already talked about the idea of functions. They're what the system does. Here's something fairly obvious, the idea of resources, people, time, and money to generate the system. And there's something called binary constraints, like it has to be legal, or it must be built in the US or something like that. Those are different. Now here is a full map of various kinds of requirements. This is from a book which you can have a free copy of too, called Competitive Engineering, where I define all these different types of requirements. Basically, I'm going to be focusing on value requirements, which in systems engineering are called performance requirements. And here's that subset I mentioned, the idea of quality requirements, and here's two other types of performance requirements. So I'm in this area only, and I'm not going to talk about all these other things. If you're interested in them, no problem. Get the book, and they're all thoroughly defined in a glossary there and show how to use them. But I think the value requirements are so critical and special, and people don't do much good with them, that I wanted to focus on that. Now, a lot of people have an environment where their main source of requirements comes from user stories. And a quick remark on that, user stories are very interesting because they have this fantastic structure of three different things. They actually have a stakeholder, which they call a user. So I actually think we should have not user stories, but stakeholder stories. Think about that for a moment. And then they have the story, which is usually mumble a few nice words, but it's not precise enough, not detailed enough for large scale systems like a health system of a country or a military system or a space system. But they're probably more than good enough for very small systems and things where it's not too critical what happens there. And then there's the justification, why do we want this? My recommendation, if you have non-trivial large-scale systems, is that we take the user story, if we have that culture, and we translate it into what I'm going to be talking about today. One thing we do immediately is we translate it into something which is quantified. So we actually move into software engineering for real the moment we do that. And that's what I'm going to be talking about today, how to define any user story ideas as a scale of measure with points on the scale that we wish to reach. Okay. So I view user story as kind of a high level thing. I don't call it a user story. I call it an ambition level, and it's just some of my clients call it a headline, and it's fine as something more than just a name like usability, but it's not fine when you're building, say, a mission to Mars or something like that, or any other large or complex problem. It's too simple for purpose, and we need to do something about it, which is the subject of my talk. Part two, here's this same graphics. The function is an oval. The so-called the value requirement is an arrow. The arrow is moving from minus infinity to plus infinity or something like that. It's a range there. Now here's the real, this in theory, here's the real range that we're interested in. On the lower end of the range, we have what we call a benchmark, and that's how things are today or right now. Or this is actually systems analysis. You know, our competitor has this level, and so we have to at least be this much better, and I call that a constraint, tolerable level. And ideally, to win, we need to go to a target level, which is this level. Okay, so I'll be speaking about these a lot, but basically there are three levels on the scale of measure: reference point of some kind, which we call a benchmark, a constraint, the minimum you have to do, and a target, what you really would like to get to for success. Okay, we're talking more about those later, so if you didn't get all of that right away, we're going to get back to it. Okay. So here's a simple little example, and here is a security requirement, and here's a scale which is readable: the percentage probability of detecting a hacker within 5 seconds. Okay, I didn't say that's the only way to do security. It certainly isn't, but it's just a simple example. Now, here's a benchmark level that last year we had a 10% probability of detecting a hacker within 5 seconds. So what is our project going to do? Well, by the end of this year, we'd like to get to 80%. That's our minimum, our constraint. Our system will be at a tolerable level. We can live with it. Okay, but that's not all we want. We really want, by the end of next year, to get to 98%. That is the stakeholder wish level. We'll be talking more about that. The wish is also success level, and I threw in a little link to a book manuscript I've written called Success. If you're interested in how to succeed always and never fail, you might like to get that little free booklet there. Okay, part two. Oopsie, I managed to get, there we go. Notice top causes of project failure, and all of these 5 things translate into communication about requirements. Okay, so we know that if we don't have good enough requirements methods, and I think most people do not, then we're going to get failure partly or wholly in our project. Now, my first recipe is that things that vary, which are critical, which are these values and qualities, we need to define them much better. And we start off by defining what I call a scale of measure. Okay, so the scale of measure is quite simply a better definition of, for example, security or user friendliness or something like that. And then once we have that, we can define failure. In other words, a certain low level is not good enough and is a formal definition of failure. And our team can be very conscious of the level of failure there and keep away from it. And then the other thing is that once you've quantified stuff, you get greater clarity than just saying improved security. You say 95% security by next year, okay, on the scale of measure. And teams can work better together when they communicate and all understand exactly what their objective of their project is and the point of their teamwork is. Okay, so there's more there, but let's move on. Okay, now the point of a scale of measure is that it has to have a useful meaning. In other words, if you achieve something on a scale, stakeholders will appreciate it, they'll value it. Okay, And what you don't want to do is pick a scale because it's easy to measure. You want to pick a scale, even if it is difficult to measure, that makes sense to your stakeholders, so that when the team is working towards things on that scale, they're doing relevant work. And there's some other attributes here, but I won't go through the whole list. Of course, it should be intelligible and reflect the values perceived by the stakeholders and things like that. Now, if we start off with a user story or ambition level, what's that? Well, that's actually sometimes politely call it the management bullshit level. And you will find that all over the place on the slides that started your project with some bullet points and some nice sounding words. Politicians do this all the time, and we're used to it, and that's okay. There's a certain purpose of being a little bit vague and a little bit high level, but that doesn't mean we stop there and that's all we do on large, serious projects. You know, if Kennedy says we're going to get to the moon and back, there's a lot of work by a lot of people detailing how to do that before they actually achieved it. It wasn't enough that Kennedy just said that and everybody had that as their lodestar, their North Star. So here is a citation, a real one, from Elon Musk at that date. Before performance, Tesla prefers to focus on safety first. Well, that sounds very nice, okay, but is it measurable? And so I've tried to convert it into a scale, percentage of average passenger safety rating by the European, rating associations. And so that's a good start. This says, aha, we can make it in this idea of how much Tesla prefers to focus on safety. We can make it into something numeric. We can define it. Here's the same thing. Here are some of the things I had to think through before I could come up with that scale of measure. It's a large number of questions, like, would Elon Musk buy into it and appreciate it? Would it really measure safety as understood by, for example, the certification authorities for cars, and so on. So here's a little checklist of the kind of questions you have to ask yourself to move from a vague, nice sounding thing to, sorry, I keep on pushing wrong buttons here, to a scale of measure. Okay. Now, by the way, here's some other answers to questions where we get scales of measure. Here's a little link to a chapter of my competitive engineering book where we have a lot of ready-made scales of measure. Here's the list of them, but if you're interested in things like security or adaptability or usability, you can get ready-made scales of measure, and then you can tailor them to your own, so you don't have to invent them from scratch. You don't have to reinvent the wheel. Okay? The point of this is also that many an idea like usability is really just an umbrella title and actually needs to be decomposed into several related things like these, and together as a set they make up what somebody calls usability, but each one has different scales of measure and different measures. So I'm pointing out that often when it seems difficult to make things measurable, your problem is that you have to decompose it first into related but different kinds of things and quantify them. And then the usability is really the set of usabilities you get from the components there. Anyway, this is nicely detailed in this link here. Scales of measure are one thing, but I have something called a meter. We'll get into a little bit more detail towards the end here, but the meter, some of you would call it a test process or test method, okay? And it's like, if I have a scale of measure miles per hour, we know that we need something like a speedometer to measure, or maybe a police radar gun, or some other measuring device. But the point is that scales of measure are one thing, and ways of measuring things on the scale of measure is another. So, but you can't decide the measuring instrument, you can't decide a speedometer until you've decided that you want to do miles per hour. You can't have a voltmeter until you've decided you want to talk about volts, that kind of thing. So we need to distinguish between the idea of scale, which is an idea of quantification and numeracy, and the meters or test instruments, which are the practical way of getting feedback after a sprint, what has been delivered and what values are we actually delivering. Let's see. Okay, that's enough of that. Now I'm going to introduce the idea of scale parameters. So let me just read this vehicle safety scale for you. The star rating number for a person type and a car specs for safety equipment with alternative model validity, publication date by a rating agency. Now, what are these things? Well, you can probably guess these are high-level general ideas like person type. And person type could be like a first-year driver or a racing driver or something like that. And what we're doing here is we're building a model, and this is for complex systems, not very, very, very simple systems. We're building a model, and we're saying, I have many different person types, and some of them are more important than others. And some of them I want to deliver value to earlier. So I need to define all the person types and all the car specs and all the safety equipment. We'll see detail on that in a moment. And then I can select the combination of these things that is my first priority for early sprints or delivery. This is very advanced agile. This is a way of decomposing, in this case, our value delivery into high priority value deliveries so we can deliver them first. Okay. So here's that same scale of measure. But here we've said, here's the person type, all of them. The level we want to get to is 5 stars by next year. That's the level we want to achieve. But we want to do that for all people, for this car spec, this safety equipment in the car, this model validity, this publication date, and this all rating agencies. So I'm using these to select the slice that is critical or interesting for me to deliver next or early. Okay, so this is a way of decomposing large complex systems and prioritizing delivery to critical components or parts of the stakeholder space. Let's see, now this initially might seem a bit complex, as opposed to just writing some simple words here, but I would argue that this is a way of simplifying very complex problems. By the way, I wrote a little booklet for fun about simplicity, and if you want it, it's right there. So sometimes you have to have complex methods to enable you to deal with simple things. Okay. Now, another way of getting a hold of these scales of measure, I said you could get them from my book, for example, but we've actually taken the book and put it into an app or a tool, and here they are, literally taken from the competitive engineering book. And then if I say, well, I'd like to get maintainability scale of measure, I click on that, and it automatically puts it in the scale, and then I can start doing things with it, defining it for my particular environment. So I can reuse a general pattern or of the scale for specific new and different domains. Here is that same maintainability, which is sort of a mean time to do something, mean time to repair kind of idea. And here we've taken the system and said, well, the systems we're interested in are databases, central hardware, internet, etc. And the failure type we're interested in is power failure. They're very interested in that in Ukraine right now, right? Sabotage, component fault. And the conditions we're interested in is database recovery, logic fix, component replacement. Okay, so we're tailoring to our environment by deciding to have exactly these types of systems, these types of failure types, and we're building a model here, by the way. This is an advanced modeling technique, if you haven't sensed that already. The tool we're using is down here. Somebody wants to know about that. So let's see, just check for different things. Check my timing. We're okay. 21 slides into about 40. So should be okay. I have a belief system for any project I ever do, including some very large ones at places like US Department of Defense and Boeing, for example, where the first thing you want to do in the first hour on the first day is say, what are your top 10 critical values? Okay, here's a paper on the subject, top 10 critical requirements. Go get it. And I found that I can get a management group to tell me what their top 10 are. Maybe they'll come up with 20 and we'll find 10 of them that are more important than the others. And what I believe you need to do is to define these top 10. This is your success definition. And to focus on delivering them and forget everything else for the moment. When you've delivered the most critical top 10 things, you can then attack the other 10, or there will be an eternal queue of things to do. But this is a way of focusing, and we found that in one single day, we can brainstorm the top 10 and get teams working in parallel to quantify them the end of the first day without any previous training. Okay, so information about that is, among other things, here. And I've done that on, for example, large Department of Defense projects and projects at Boeing and things like that. So that works. That's requirements simplified. One day, top 10, quantified, and then all other effort is focused on delivering those 10. Management need only ask one question: how are we doing on delivering the top 10 critical things to our goals? Everything else is just a detail below that. Here is a full requirement definition in my planning language. And so here's that ambition level. We were working on the problem of the London air quality. So here's that management bullshit: drastically improved air quality in London, says the mayor, according to the Paris Accord. Okay, but here is the scale of measure: number of people, etc., with time, pollution, area, etc. Here is a meter. That's the proposal, high-level proposal for testing. Here is the status at a certain point in time where you are. Here's that same status up here. And then as we move along, here we're moving towards a tolerable level, two different ones, maybe for different conditions, different point in time. And then when we pass the tolerable level and we're alive, we can live with the system, we move towards our goals, which are our definition of success. When we reach our goals, by the way, we might do what my friends at Nokia like to do, because they were Finnish, I think. They like to go for stretch goals, really just amazing, mind-blowing things. Okay, maybe a bit early for that. Okay, but so here you see an example of one whole air quality, in this case, requirement with a whole lot of different parameters in language. Okay, here you see the detail on that scale of measure. So there's the scale of measure, but there we have taken each one of these scale parameters and defined it by breaking it down to a set of different conditions that we can then prioritize and say, I want to do the adults for carbon monoxide in a time span of 6 months. Okay, you can choose a set of things to prioritize. This is your sprint. This is how to decompose into delivery sprints of value. On that scale, you saw a number of points, numeric points, and there are 3 classes of them. The first one we call benchmarks. This is, if you like, systems analysis. And we're actually bringing systems analysis into the requirements specification. And really it's a kind of background information about how things are with your competitor, are with your old systems, will be with your future system if you don't do anything about it, that kind of thing. And so the first and most common type is simply the past level. If you're like a business analyst or systems analyst, will dig up and say, this is how polluted the air was in 2016 for nitrogen dioxide in Greater London, 135, is that micrograms per square meter, okay? And here is the wish level. That's a what we call a target. We'll look at in a moment, to get about twice as good by 2021. Okay. So another benchmark level is called status. Now the past, which that's really a fixed point in time, like something just happened and that's the end of it. Status is real time, sprint by sprint, accumulation, increments, living and breathing system feedback. So we use status to tell people planning their next sprint, where were we after the last sprint and where are we trying to get to? Long story short, status is living real time feedback and measure of what's going on. Third type of benchmark is called the record level. This is the state of the art. This is the Guinness Book of Records. This is the best anybody's ever done in a certain sphere. And the record tells you several things. If people don't know what the records are, they are not experts and they're not technically competent. Technically competent experts in almost any field, think sports, can tell you the records. They know it. Okay. The records also tell you that if you set your wishes to go beyond the record, it may be possible, but it may be very risky, very costly, and much more delayed than you could imagine. Okay. So if you want to be on time and on budget, maybe you don't decide to break the record. That's just a highly risky endeavor. And the other thing you can do, if you know what the record is, you can ask, what was the architecture or design? Should we copy that or should we try for something even better? A lot of interesting things happen when you use the record. And then the trend benchmark is sort of like the past, except it's into the future. In other words, the technical debt is at a certain level, but in 2 years, it's going to be twice as bad. The security is pretty bad, but it's going to be even worse in the future if we don't do something. But the trend for our competitors is that the security is going to be 10 times better because they're investing heavily in it. So trend is sort of like what marketing people like to do, is looking ahead to the future for you and your competitors, but with numbers, with pretty clear ideas. So here's a trend specification there. Okay, looking at what. Okay, so part 5. Here's this arrow where our value scale is, and here are 2 points on it we've referred to. The tolerable limit says that if you get here or better, your system can be tolerated. It's, we can live with it. We're not terribly happy, but we're not going to say it has failed totally, forget it. And below the tolerable, you have an intolerable situation, which means you're not going to put the system on the air. You're not going to deliver that increment to a customer. It won't meet the contractual specifications, that kind of problem. Okay. Now, the goal level is, let's just say, if you get to the goal level, it's defined as being better than tolerable. It is the lower limit of success. And you can then get better and better and better, get more and more success. Okay. So I just want to introduce those concepts. Many people, when they set numeric goals, just have one number, and it's maybe one of these, but they don't tell you which one. And it's a powerful, useful idea for many purposes, is to make a distinction between the minimum you have to achieve numerically in security, for example, and the successful level. One reason for that is prioritization, deciding what to do. And it's obvious that your first priority is to try to get to tolerable limit. And if you have top 10 critical objectives, it means getting to the tolerable limit for all 10 before expending effort bringing any one of them up to a goal level. So your second priority, when the system is in tolerable state with maybe 10 different critical values, second priority is to work your way up to the goal level for all 10. Okay, when you reach the goal level for all 10, it is formal success. Okay, And then your third priority can be, we've got more time and money and people. Let's go for moving towards a stretch level or something, even more amazing. Okay. So in other words, one of the functions of the tolerable and target goal levels is to help you prioritize a balanced set of maybe 10 different critical objectives. This is managing your project and getting it done successfully. Let's see. Okay, I'm going to skip that part 6. Okay, so there's a class of things called targets, which I've given you some examples of. There are wish, goal, and stretch. Okay. So here's a slide that basically says there's no point in setting targets unless you have really clear scales of measure to set them on. And I've talked about this before, but here's our building a scale with lots of conditions so that we can very precise, that number has a more precise meaning when we start applying this scale with its scale parameters. Okay. Now, the wish level is the stakeholder wish. Okay. And the problem with stakeholders is they know what would be nice, more or less. They may change their mind every day, but they have a, you ask them, they'll tell you what they dream about and want. But the problem with that is they don't know how much it will cost. And they don't know if it will cost billions of dollars and they can't afford it. They don't know if it will take 20 years and they want it yesterday. Okay? They don't know if it totally collides with everything else and every other stakeholder and steals all the resources from all those stakeholders. So what we do is we say, look, a stakeholder should be permitted to wish in their area, okay? But we will not commit in the project to delivering a wish level just because the stakeholder said it, okay? Because there are a lot of other considerations simultaneously, the other 9 critical objectives, the other 30 stakeholders have to be considered. Okay, what we do is we put that wish level into the architecture or design function and see if there is technology that can deliver it at all. It's not outside the state of the art, and how much it costs and whether it fits together with everything else within the budget. If here's just okay, drafting wish level. If in fact it passes these tests, we say, okay, we'll convert the wish to a goal. Okay, and goal is a signal saying our architects have found that this is technically possible. It's well within budget and deadlines and personnel and everything else. So our project is hereby committed now to that. Okay, so wish not committed and goal is committed, but it implies architecture has found technical solutions and their costs is a prerequisite. That's something people don't seem to think about. They say, well, if the customer asks for that, they're the customer and they're paying, they're going to get it. And that's why projects fail and are late and are over budget, because I'm just a girl who can't say no. I'm in a terrible fix. That problem. Okay. And one level beyond a goal level is, as I said, my friends at Nokia taught me, the stretch level. That's when you're really ambitious and really competitive, and you're saying, if I have enough resources, or maybe after initial deliveries and initial budget, there is a level that some stakeholders would think was just fantastic and competitive, and that is our stretch level. And we're going to put a number on it. We're going to explain why people would like it and who the stakeholders are. And if and when we have the resources, we're going to go for that stretch level and be ultra competitive. There's a reason why my book is called Competitive Engineering. Okay. Okay, we're doing fine on time. This is really fun. The John's Weather Forecasting Stone. You should get this slide and read this slowly. It's a real one here in Norway. Okay, but it's amazing the degree of measuring capability you can get from a stone. Okay, anyway, meters, as I said, are the specification. Usually here a one-liner, high level, roughly how are we going to measure that? What is the test process? Basically, it's high-level test planning, test design, but it's usually not extremely detailed test planning. And you can actually have, how many different ways do you have of measuring the speed of a car? Well, I already mentioned the speedometer. I mentioned the police radar gun, but you should be able to think of several more to start. If I'm just eyeballing the car going by and said that's doing 50, is also relevant and useful in some cases when you don't have anything else to help you. So one scale can have, if you're going to get any feedback whatsoever, it needs at least 1 meter at the end of the sprint. Okay, but you might need a meter at the end of a series of sprints when you're doing worldwide distribution before you release it to the world. You might want a completely different level of testing. Okay, and you might want to have a third meter built in automatically into the system to measure system in operation. Okay, so, but that's okay. So one scale, and if you want any feedback whatsoever, you've got to have some way of testing it. Meters are interesting, and we can go deeper, and this applies to any test process. Here's a list of the qualities of a test process or a meter. Okay, and we don't usually think about that. We just have a test process and, test-driven development or something like that. But how accurate is it, and how relevant is it? And what about the repeatability and the sensitivity and the credibility and the legality and automatability and privacy? Okay, anyway, a deep subject. The whole area of tests and meters could be more of engineering and less of just intuitively learning a method and following it. Moving towards the end, I have a thing called background parameters. Now, I've already shown you some background parameters like past, and even the ambition level is background once you've defined a scale and a number, which really replaces that high-level vague ambition level or user story. So background is not the real requirement itself, but it helps you deal with the requirement. So here are some of the reasons why background specifications need to be embedded or integrated into the requirement specification. The whole list of them, but this list begins to solve some of the problems of risks and priorities and quality control and on and on and on that we're not very good at. And the reason we're not very good at some of these things is we don't have enough information to, for example, do proper quality control of the requirement. And the background information gives you little hooks to use to compare with other things in the specification and understand that specification better. Okay, so here are some background specifications that I haven't talked about. Owner is who is the specification owner? Who has the right to change it and the passwords to do it? Okay, that's not a requirement, but it's very interesting information about the requirement. Assumptions, right? For want of a nail, the kingdom fell. Okay, issues, things that we brought up and nobody has a good answer, but I want to record it there and maybe get it answered before we, put $500 million behind it or something like that. Dependencies, very interesting stuff. It's not a requirement, but it's maybe going to screw up the requirement if you don't deal with it. What are the known risks with the environment? Like this is a new technology we're going to need that we've never done before. Okay, what's the rationale? This is the same as in the user story, why we're going to do the user story. But that's background information in the user story and here. Okay, ambition level. Well, some people use that as their only form of requirement, but once you translated that, as I said, into a scale and say a goal level, okay, this is really just background information that some CEO said, that's what I want. Elon Musk said, I want that. Then that's just background information. So long story short, Language has a very large number of background information ideas, which have very many useful purposes. And I normally embed them in requirements. And we don't do it all at once. We often accumulate digitally through time, accumulate the knowledge of a requirement as the project goes on and as we learn. Okay. Here's some more background stuff regarding responsibilities. For example, who's responsible for implementation and who's responsible for delivering the value and who's the owner of the spec. We did that before and things like that. Okay. So I sometimes find that over 2/3 of requirement specification is not the actual requirement. It is actually background information that we bring in, collect, digitize, and keep up to date, hopefully, for our requirement to help us manage the requirements for large-scale complex systems in the long term. Okay. Here's some stakeholder details without, don't need to talk too much about it. Now, I actually managed to stop 9 minutes before the hour, and I'm done. Here's the free book. Linda will be giving you that link in addition, and I'll turn it over to you, Linda.
Okay, if you have questions, please go ahead and type them into the question area. I'll get to them in just a couple of minutes. Here's my contact information. Again, it'll be in the slide deck, but go to softwareexcellenceacademy.com/webinars for the information about the upcoming webinars and to register for them, /live classes for the CSQE class, etc. And here is Tom's information and pointers to a bunch of links and etc. And we will now go to questions. Colin says, hello, Tom. Thanks for sharing your wisdom. Do you think if it would be okay to use only one quantified target value on business objectives and define other separate quantified objectives if a more ambitious value on the same scale is of interest?
Oh my gosh, that was a complex, and I don't want to use a lot of time clarifying the question. You can try it, and it's certainly better to quantify some critical things rather than none. So you might like to start off. My experience with business people is there is no one objective, nothing simple like profit or growth. There are, just at the business level, there are clearly, immediately, and they'll tell you what they are, multiple business objectives, values, which need to be quantified. And then in addition, the technical things like usability and security come in. So you can try with one and get some experience with it, but you're going to end up with multiples, is my short answer.
Okay, Colin, I have taken you off mute, and you can unmute yourself and talk to Tom if you'd like to a little bit more and clarify the question, if necessary. And I don't see him taking.
There we go. I'm off mute. No, thank you, Tom. What you say, what your answer makes a lot of sense, is that with experience, I would probably find that more than one value is relevant and pertinent. So yeah, thank you for answering the question.
Okay, John asks, thank you for your talk, Tom. I downloaded the value requirements book. How prevalent is the use of language in discovery, e.g. experiments, etc.? So how prevalent is the actual use of language?
Okay. The funny thing about language is it's been adopted by certain major corporations like Intel, Hewlett-Packard, IBM, Boeing, etc. And for example, at Intel, for over 20 years, they've trained people in language on 2-day courses, 20,000 engineers. That's very prevalent. It is the obligatory language for specifying Intel products, okay? Now, and more or less the same thing with these other large corporations. They've taken a look at it and said, we're going to spread it to all our employees, and they've done it, okay? Now, but amongst ordinary people, probably most of you listening, your corporation probably doesn't know about language and probably doesn't practice it at all, okay? And I don't know, that's one of those mysteries. I think maybe smaller organizations are not as motivated. And one reason these organizations that I've talked about, Hewlett-Packard, Intel, IBM, are famous is that they have pulled in advanced technology to keep them competitive like this. That's what they do, keep themselves competitive. Smaller organizations would probably rather die than learn an engineering discipline to do requirements.
I could agree with that. I've seen a lot of small to medium-sized customers, because those are my clients, that don't even define things like security requirements and safety requirements. So I've taken a lot of things, lessons learned from your language, and just turned them into high-level templates for defining a security requirement and that kind of thing. So, half step there, as it were, for at least
Yeah,
getting them to start thinking about quantifying requirements other
that's
than
right.
just the functional.
So, sure. So sometimes that's the best you can do. Yeah, sometimes your organization is not ready at all, but maybe one project is so critical and led by such imaginative, bright people that you can get them to go in this direction and they will appreciate it. Okay.
Mm-hmm.
And sometimes if you feel that you are the project manager or you're close to being that, you can at least experiment with saying, what are our critical objectives and can we make them more clearly? Okay. Serious people will always value that clarity. Other people who are quite happy to fail as long as the corporation keeps on paying them don't care. For them, it's just a bother.
It's like I still go to companies that aren't doing the fundamentals of configuration management, that alone good requirements engineering in a systematic manner.
Yeah. So, yeah, but
Go
let's
ahead.
consider the question answer. No, we'll consider the question answered for most. There's a lot more I can say, but there's not a lot of time.
Monica says, thank you very much. And Teresa says, wow, great information. Thank you for sharing it with us, Tom. And those are all the comments and questions I have. If anybody wants to, otherwise we're at past 1 o'clock and we'll call it a day. I'm just
Good evening
hovering
to you
here
all.
and waiting to see if anybody else is typing, but I don't see anybody else.
Feel free to use my email to ask me questions. You'll probably get an answer today.
Okay. So with that, we will close the webinar. Thank you all for attending, and we hope to see you at my webinar next week.